share slides?
And there,
Oh,
yeah. Are you ready?
yeah,
Okay.
we can start.
Okay. Hello, everyone. Thanks for coming. We'll be getting started.
Steve.
Yeah, we're starting. Thank you. Uh, well, this is the COSE meeting. Welcome again. And okay, this is our note. Well, I believe you have seen it. It's Friday after all, and yeah, you have also clicked. I have read this while registering, but uh, you should be familiar with this prior to uh, d- participating in any discussion. And please, if you have any questions, ask someone in leadership. Okay, this is our note really well. I believe in COSE we have always behaved very professionally and have been nice to each other. But yes, please uh, do that, be professional and respectful of the other participants. And if you notice anything, uh, um, yes, worrying, please reach out to us or the ombudsperson. Okay. And here are some tips for the tools. Um, if you haven't already, please make sure to use the Meet-Echo client. It's important for tracking presence and for also queuing if you want to participate in any discussion. And here you can find some more relevant materials for our meeting today. And we'll need some note takers. We already have a person in the room that volunteered, but please, if you can help with the minutes and also if you participate in any discussions, please check if as they are your view is represented in the minutes and if it's represented correctly. And with that out of the way, moving on to status of some drafts. We have two new RFCs, namely the 9596, that was the COSE tip header parameter, and 9597, which is COSE WT claims in headers. Thank you to the authors and everyone that helped those drafts become RFCs. Then moving on to some other working group document status, we have the key thumbprint draft that is in the RFC editor queue. I believe we only need confirmation from a few of the authors whether they are happy with the latest version, and then it can be published. And we have two more drafts that are ready to request publication. If we don't hear anyone at this meeting or right now jumping at the mic to say we shouldn't, we'll just click the button after the meeting and request publication. Not seeing anyone run to the mic. So moving on. And yes, we have, yes, someone wants to say something or maybe not. Okay, moving on then. So status of some other drafts, the COSE BLS key representations is waiting for BBS signatures back, and the COSE CBOR certificate, CBOR encoded draft is uh, it needs some updates, but the authors were unable to provide them in time for the meeting. Okay, and this is our agenda. Um, we will start with the remarks and then some post-quantum crypto drafts, the hash envelope, HPKE, and a few more drafts from Hannes related to HPKE, and yes, then Merkle mountain range proofs, and finally the COSE uh, Cometer CCF profile. Ah, okay, and we'll have plenty of time at the end. So if you have any bashing of this agenda, please come to the mic now.
It's actually draft IETF in the draft steel.
Uh,
Envelope?
ah, yes. Yes.
So John Gita Data Trails, very minor agenda bash, but just we've had to move some presenters around for availability reasons. So it'll be me doing the hash envelope, and then Robin Bryce is available and registered for the Merkle mountain range proofs.
Okay. Okay. Well, with that, I will let Mike Prorock talk to us about the post-quantum drafts.
Mike Prorock here. Wait for the deck to come up. And thank you all for being here on a Friday afternoon, in fact. So next slide, please. So some quick updates here. Dilithium is on 04. Had some pretty good thorough reading, especially from Cedric, Roy, and a few others in the room. We've got tests in place thanks to Ori and some others. Unless they're, and this is an area I would love comment on from the working group, but I do not think there is in any way, shape, or form we should mix and match pre-hash versions with non-pre-hashed versions for a variety of reasons. So I think we stick to the just straight dilithium as is, and then based on requests as stuff gets a little more hammered out and tested on both the CFRG side and on the PQ list side, then address the pre-hash version, because I think that covers a lot of things. I think it's a useful thing, but it should not get mixed in from a registration side. I would just pause now if there's any comments about saying, yes, we should or should not pre-hash all at once. Mr. Jones.
So speaking only as an individual, John, he asked the pre-hash question.
Doesn't everybody ask the pre-hash question?
It is the case, for instance, for FIDO authenticators, that you don't want to send a big thing over NFC that you're going to then try to sign. I was talking with Deb Cooley about this earlier, and she said that the NIST document is written in such a way that you could do the hash inside the container, you could do the hash outside of the container. It is the same computation. That said, you need to know inside the container whether the hash was done or not, or it's not the same computation. And so there is an argument for giving a signal, probably a different algorithm identifier, saying, I've already done the hash, don't do it. So I would be in favor of having separate algorithm identifiers to provide that signal. It is the same algorithm.
Right. So we're kind of running.
John, go to the mic.
So we're kind of running into the same thing with EG25519 now, where we have effectively two different versions of the algorithm, because, and you know, ED25519 is not really appropriate for TPMs and secure elements. So I know in some of my conversations with people that shall never be mentioned, there is a concern around supporting pre-hashed versions of these post-quantum algorithms for being able to do the appropriate parts in the secure elements. Um, so we probably want to have different algorithm identifiers for the two different things so that the secure elements know what the heck they're doing. In some cases, you may actually want to do the non-pre-hashed version if the thing that you're sending in isn't so large. So in CTAP, because we're only sending in the hash and a couple of other things which are getting signed by ED25519, it's not a big deal. So the normal FIDO ED25519 signing is not the pre-hashed version, but when we, in the raw signing extension that's working its way through, because we will likely be signing verifiable credentials, etc., we have to support the pre-hashed version.
Yeah. Thanks, John. That tracks with everything I'm seeing as well. My inclination, unless the chairs or the group says otherwise, is to say let's get the non-prehash version through so that the algorithm itself is cleanly defined, then add a separate draft which is just focused on the registrations for prehash, and that way we have those cleanly separated out. We can make sure we're calling out exactly what hash mechanisms are appropriate, and how that's identified. Because if we don't identify the hash mechanism cleanly, you'll wind up in cases where you've signed something that has not been hashed appropriately for the algorithm you're trying to apply.
Are you volunteering to write those other drafts in a timely fashion?
I can actually write them up within a week or two and have them ready for working group submission prior to, I think Bangkok is next. So
That sounds like an affirmative answer to me.
excellent. With that, I believe that we are likely ready for working group last call. I would love final reads, any edits from broader side of the group on the dilithium side.
Does anyone in the room or in the virtual room want to speak to that? Hearing none, I concur that we're ready for working group last call. We can start that after the meeting.
Thank you so much, chairs. Next slide, please. At some point, that slide will become. Oh, there we go.
No,
Perfect.
it's
No,
just
no, no. 6. Oh, go back. There we go. All right. We did the bulk of the work on the FIPS 204 side of things and MLD, or 205 and MLDSA, et cetera. So that's all in good shape. Based on that, now we're following closely behind with the Sphinx work. We went through, double checked everything. Now that 205 is out and clean and been read, there's a little bit of a lag on the implementation side for Sphinx compared to dilithium. So getting test vectors in there and stuff like that, that's going to be a little bit shaky. I think once we have good reviews and confirmation of the test implementations were there, we obviously need some additional eyes on that. I know Ori and some others jumped in to help with the implementations on the MLDSA side. We now need to do the same thing with the SH, side of things. So if there's recommendations on the list for an implementation, or someone has one handy, maybe something that's also being used for the LAMP side, that would be great. That's kind of where we're at. So until we get some good testing and say, yep, I've got one working with another, I mean, sure, it works fine in theory. We've identified the algorithms, but that's a works fine in theory, not tested and confirmed. So once we're there, and I think that can all happen hypothetically in the next 30 days, but it's really just waiting for implementations to get validated and tested. So I will pause to see if there's any questions around the Sphinx side of things before moving on to the redheaded stepchild. All right. Now moving on to things that involve floating point math. yet also have nice small keys and signatures. So that's kind of a problem because these is probably the most desirable properties we have, yet it involves things that we can't really use consistently in the embedded side. Once we have 206, we are teed up, ready to go and to drop that stuff in, but it's just waiting. So I don't know if anyone from NIST cares to comment, but we're really waiting there and in hold. So we've, I would ask the chairs, do you want me to rev the draft just with like some editorial cleanup, just to kick a new version up so it doesn't show as expired? Not sure of preferences there. It just, you know,
If there's editorial work to do, that it's always open season on that.
yeah, I'm not sure how much there is because we don't know what's going on in the final. So, but I'll maybe take a pass and kick something up with a nicer intro. Gotcha. That's what I was asking. Yeah, yeah. Perfect. Sounds good. So if there's any steps requested for Falcon from anyone who has inside knowledge of somehow how this is magically going to become a thing before we get a draft, I'm all ears, but we haven't seen anything yet, and I'll continue to watch the list for any comments there. And as soon as we get something from NIST, we'll update the draft and push it out probably about 2 weeks after, assuming test implementations exist. Perfect. I think I might have one more slide, maybe, don't recall. Yeah, that's basically it. We touched on the pre-hash side as well, so I will follow up on that with some drafts there. Any other next steps on the post-quantum side besides that which we've noted? I know Mayo and some other things are moving out, but we've got to see them move through qualification at NIST before we could take action on them, I think, at this point. Any comments from the group?
Is there someone who's going to do the test vectors for the second one?
I definitely will get some Sphinx stuff. I did. The one author that has helped with some of this was at Google, then moved on, but I think he's still got some libraries sitting around. So we'll reach out to him and see if we can't kick that along.
Anyone else?
All right. Thank you so much, all.
Thank you, Mike.
Next is the hash envelope.
Okay, yep. So this shouldn't be brand new to everybody, but there's been quite a lot of work since last meeting. So give an update and some calls for the hash envelope. So quick overview, what we're looking to do is define COSE header parameters to, saying that's just curiously related to what we were just talking about, to suggest that what is in the payload of the COSE hash envelope, the COSE sign 1, in fact, is the output of a hash function specifically. Enables faster validation in cases where the payload is not necessarily available or not required or just not suitable for inclusion in the whole envelope. We'll get to why and where that happens. And then some potential extra helpful stuff to glue those two statements together to hint back to where the payload might be or how you can validate it if you want to. There was a lot of discussion at IETF 120 about whether you can really trust a hash without the original object that it was derived from. And the answer to that obviously is it depends what you're using the hash for and how deeply nested it is in the envelope. So it's the overview of what we're doing. So current state of COSE in general, we have attached payloads, which are lovely. They're very clear. That's not lovely and clear. Apologies for the overwritten stuff, but I think you. Oh, it's the old one. Does that mean you deleted the new one? We can. Oh, there we go. That's got the slide numbers on now. Yes. So, apologies to anybody who was upset about there not being any slide numbers. There are now slide numbers. The way this works, which hopefully everybody knows, is you have the envelope, you have a protected header, which is included in cryptographically bound. That's important that you can have metadata about the thing that's going in. And then you have the thing, the payload, and kind of there you go. I think there's one more. yeah, and then you get a signature over both of those things, which gives you a nice tight package for, here's my metadata, here's my thing, and you can't validate one without the other, you can't separate them, you can't pretend this is about something that it isn't about. So in implementing a bunch of, mostly coming out of Skit implementations, but also sort of general purpose COSE handling, we've been working with people like the VCon group, who deal with virtual conversations, which can be very large. So if your payload VCon goes into there, then we start getting into questions about how large the envelope can be. And hit the button again. An interesting kind of ironic thing about using CBOR here to be super compact and really nice is that, well, it's all well and good compacting 500 bytes into 25 bytes. That doesn't help if you've got 50 gigabytes of already compressed payload just stuffed in the middle of it. So we start to wonder about issues like, there's basic size issues, but there's also issues of, what if the payload is stored somewhere else that you can verify? In many cases with larger sort of big data sets, training sets for AI models or software supply chain artifacts, they only live somewhere else and you have to have protected access to go and get them. And of course, there's the issue that if you're in relatively high volume transactional environments, having this massive thing and passing it over every boundary just in case the whole thing needs to be checked every time is concerning to a number of our use cases. So this leads us to a question of, how do we deal with this? How do we make this better? How do we make this more efficient? Now, of course, the more seasoned among us will know there are detached payloads in COSE envelopes. So it's very simple. You just set the payload to nil. You get the signature over a protected header, which is going to have your metadata information in it. Sign that, and there you go. And the idea here with putting something like a hint, for example, into the unprotected header is that you can say, well, the thing's over there and you can go and grab it and you can check it later and like reconstruct your signing environment as a separate exercise, which might be okay, but actually it turns out to have very awkward practical constraints to it, because if anything is a long way away or a long way away in time that you're going to want to verify this thing, or is behind protected access, all of these things prevent you from having any of those nice, neat, constrained cryptographic properties of binding that you thought you had before. So then we're back to having a massive payload again. So the solution to this that we thought was kind of interesting is the COSE hash envelope. And what it does, oh yeah, I don't remember what this there. Is to make an explicit payload. So this is attached in the sense of a COSE envelope, but the explicit payload is a hash of something, and then you get the signature over the whole thing, and we can give hints. Again, this is sort of eerily echoing in a much less sophisticated way, but kind of echoing what Mike Prorock was just saying, and John at the mic, that we obviously want to tell the difference between our payload happens to be a string of bytes that is the same length as some common hash function, and no, this actually is the output of an explicit hash function of something.
That's right.
And so this is what this is intended to do, is to have a specific content type. We've called it this for now, but it can change. That's going to be part of the last slides. So we have an explicit content type to say, no, this is the output of a hash function. So this is effectively COSE sign 1 for pre-hashed. We then have a hash algorithm identifier so that you know how to reconstruct it. And what would have been the content type for a traditional attached payload, a plain text attached payload, becomes the pre-image content type that you attach into that, along with potentially a remote payload location. And what that gives us then is an ability to still, I know, we haven't got that one. So an ability to still do standard COSE envelope management. It's just a 18 sign 1 envelope, and verify the thing if you want to, but not have to pass everything across the boundary every time if you didn't. So this is sort of what it looks like. Incidentally, I should have mentioned at the start, I'm not an author of this thing. I'm a consumer of it. I've implemented stuff, and I've been working with other working groups to implement things that use this, and it seems to work. So I can present it as it works, and I can defend what's in the document. Now, if you have questions about how the document came to be or what decisions were discussed, I don't know. I'll have to ask the authors about that. But as it lives and breathes as a proposal, we've added these 3 TBD tags. So we don't know what they're going to be, but it again fits very nicely inside the structure. It looks like this. The types and concepts are all the same as everything that's in COSE envelopes already. And it's just a matter of making space for this explicit acknowledgement that we have this pre-hashed content.
What's the -16 mean? Your TBD one?
I'm gonna ask an author, why is it -16? All right, okay.
Okay, it's the hash function identifier.
Yeah.
Okay.
Yeah, so but great question. So the reason we've got TBDs and the reason I'm standing here is because we don't want to have to sort of define some T-strum map and say hash envelope blah. We want to have it like proper CBOR. And there you go. There was feedback. As we presented a sort of very rough idea of this last time. There's been some document review. There's been some great feedback from folks, and a lot of it. I can't say all of it, but a lot of it has been incorporated, including, so all the hashes, all the layers of the hashes, all the hashes of hashes, and everything else. You know, what happens if you sign a hash and you pass it to a function that hashes the thing before you sign it? We've been through all of those machinations, and it all seems to work. We've made some clarity in the document there, and also particularly dealt with the confusion on the handling and the encoding and the kind of stuff that Mike just raised there. So it's had some review, it's been through some things, and most importantly, from my point of view, it's actually been tested with multiple versions of running code. I believe, I can't speak on behalf of other companies, but I believe there's at least one more commercial company has actually implemented this in their products and is kind of using it in anger already, jumping the gun, but there you go, it's working for them. And there you go. So
Professor Borman.
So would this be a good time to do the early allocation?
Get closer to the mic.
Would this be a good time to do the early allocation?
It would be a great time to do the early allocation. Yes.
Good.
Yes, thank you. So I mean, essentially the whole, other than to provide the update, yeah, if we may graciously request to get some pre-allocation of tags for these 3 bits, that would be very helpful.
Do you know how to do that?
I don't, but again, I'm not an author, so okay.
Okay.
We'll ask Carsten. Thank you very much. Yeah, and it should just be these 3. As we say, we've tested it both with review and in code, and it seems that this compact representation works for everybody so far. So this should be it. Yeah, so that's the request, and yeah, thanks very much. We've got 2 in the queue.
Cedric.
Yes, so actually it's the same comment as Carsten. Early allocation will be great. We are implementing it, and it would be good not to put TBDs in the code. And I also don't know how to get the numbers, but please ask for that. Thanks.
Okay. So if anybody's taking notes while I'm at the mic, we can action Steve Lasker to do the pre-allocation.
So let me just add, there is a little time-consuming thing in here, which is the working group last call for this early allocation, and we probably should make sure that we get this in next week.
Okay.
So we don't have to wait till Christmas for this to happen.
Right.
Gary? Go to the mic. Yes. John, let him out.
I think it's not a wired mic. We could just sort of rove it around. Oh, but then the camera would get stressed.
Yeah, I'm not objecting against early allocation. Of course, I'm just have a more general question, and it may not be appropriate for the speaker to answer, but maybe other people like Hannes or Carsten or Mike. When we were doing entity attestation token, we ran into a similar problem, and we find something called the detached EAT bundle, where a claim set can be excluded from the payload, but the hash included in the payload. I am thinking that is still the proper way to go, because the claim set is structured data, And this use case deals with data in a more general sense, like the VCon case, where you don't necessarily know the structure. Is my interpretation correct, or does the attestation do the attestation specs now need to be revised in light of this standard? Go ahead.
Defer to Hannes.
Yeah, actually,
Who
also,
are you?
Hannes, also in the suit document, suit manifest, we have basically the precursor to this, which have served as an inspiration for this work. And so, like, there's no point in revising these type of specifications. They are so far along in the process already. It would be very disruptive. So my take on it would be, we advanced the stuff, and had that been out there like 5 years earlier, would have been great. But
then would it make sense to put in as non-normative text in this particular document stating there are other solutions to this, but those are but those are specific to the use case, like suit or rats or any of the others which actually deal with structured data. So maybe revising the text.
So that, I came back here because on the other version of the slides, this had the draft idea, but it's in a draft. So yeah, making comments. Everybody, please make comments. We don't think we're finished here. We just want the early allocation so that we can carry on. But yeah, the intent is that there are other documents in other IETF working groups that depend on this, which will want that to be formalized. In no way does that exclude other things from using other methods, or even detached payloads or anything else. There's no, I don't think there's any prejudice on that.
Gary, could you suggest text on the list?
Yeah.
Thank you.
This one.
I keep
Or
on going
the-
back to one
the one
section. We
with
got
the
the EDN. in it.
The EDN on it, yeah.
Yeah, there we go. So Steve Lasker, Data Trails. One of the authors on the doc. The way that you can do, Gary, this is you can specify others. So if you notice, there's a type, which is part of the COSE. It's not even part of our draft that was added. And the pre-image content type. So in this case, that is a format, and the VCon example is an actual known structure. So that's what's referenced there. So at least in this case, that worked out really well, that we would know that it is a VCon type. It's a hash of it and done with SHA-256. So if you have, I would assume, I would love to test, could you do the same thing there for these other content types that you're referring to? Okay, that'll be a good test. I mean, because we do want this to be flexible, but you know what you're looking at. And that's why we've added these as supposed to be guessing. Is the payload string, that's it? Or is it a hash? Or is it a hash? How do I reconstruct that hash? And all those details.
Okay, I thought we already have a hash of the payload. So there is an algorithm identifier there, the after TBD1. And there are some algorithms that have a hashing step as their first step. Are we dealing with those? Are we doing anything special for those?
I would hope that at the level of this proposal, it doesn't matter, because there's also one step even before that. Various different types of data and data structures and formats have serialization requirements to them as well that affect what goes into the hash. So the specification here should tell any competent processor how to deal with what it's presented with. If you think we need second things, yeah, Hannes.
Carsten, sort of like there's the signature structure created, and which doesn't actually then, it would just take a bunch of the fields, the protected header and the payload, and munch it up in some special COSE structure, and would then compute whatever that signature algorithm does over it.
Yeah, I'm not sure what the signature is. I'm talking about the payload hashing.
The hash.
TBD1.
Explain your
Yeah,
question.
so I'm just wondering, do we literally apply this algorithm, or do we fudge with that? If that algorithm has as a first step a hash computation, Are we fudging with it, or are we hashing the hash again?
We're not hashing the hash
So
again.
you are fudging with
So-
it. And if you're fudging,
Okay.
then I'd rather be on the side of being very, very, very explicit
Yeah.
that this fudging is taking place.
Okay. Yeah, there's a bunch of places. One place where the document really needs some extra review is the security considerations section. So we've got
Yeah.
some bits about encrypted hashes, and we've got some bits about, you know, if you're going with plain raw hashes, then you're exposing the hashes. And if those don't cover your concerns, which I'm pretty sure they don't currently, it would be good to add those in, because there are some there are some considerations like that.
Okay, I'll do this offline.
Thank you.
Karsten, I'll make my standard comment. Can you say that on the list? Thank you.
No, but there are, I mean, there are a number of standard, like transparency logs in general, so what we're dealing with, basically split down the middle between ones that allow you to put stuff on the log and ones that insist on doing something with it, like hashing, to prevent you from poisoning the log or putting invalid stuff on it. And they work two ways around. So we just need to be very clear which one it's doing.
Just so that my understanding appears to be slightly different from Karsten's. So to my simple mind, imagine we were doing something like ED 25519, which would be an algorithm, signing algorithm that has included hashing.
Yeah.
I have a blob of data someplace at payload location. It's of that content type. I would take SHA-256, create a SHA-256 hash of that,
Yes.
put that in the payload, and then do an ED 25519 signature, which would use, what is it, SHA-512 to, or SHA-256, no, for ED 25519? No, it's not SHA-256. The internal hash is, I think, SHA-512 for ED 25519, but it would be taking all of that, the protected payload, the protected header, the payload, and doing a SHA-512 hash of that, and calculating as part of that the signature, which would go in signature. So
Yes.
So
and it would be kind of awkward and weird of us to change that, because we're fitting inside the
Right.
COSE sign one mechanism.
Okay, so I think that Karsten's question was, yes.
Well,
so
I understood the word.
So there's two
fudging
different
in a weird way.
there's two different hashing steps. One is the hashing of the detached payload, which becomes which becomes the content, which becomes the payload, and then whatever hashing the signature algorithm has over that is just what that algorithm has over that.
Yeah, exactly. So I was
Yes,
looking
two
for
steps.
a better picture.
Good.
I have a thing.
Yes, we're
Okay,
not fudging.
Good. So that makes that makes no, but that makes
Well,
the word fudging make more sense. So I'm happy with
unfortunately, I do know what that term means, but I think he means something different.
Right. Yeah, no,
so-
it's completely standard COSE sign
Yes.
one. I've got a thing.
Right.
I hash it. The output of that hash becomes part of my new message, and then I do a pretty regular COSE sign.
Yes,
one over.
I'm much happier with that. Okay, we're good.
Yeah.
Thank you. Are there more questions?
It was just a point
wait,
of
there's
clarification. I
more.
just want to make sure, because I think we closed the loop.
Yeah.
Because we talked about a pre-allocation. Does this conversation change anything to do with, should we go forward with the pre-allocation? Okay. Just point of clarity. That was all. Thank you.
Yeah, if we want to, like in the EDN, if we want to change this thing to payload hash algorithm to whatever payload pre-image hash algorithm in whatever, yeah. If we want to make that clearer, clearly we could do a better job of that, but yeah. Otherwise, it doesn't change any of the request. Okay. Well, thanks again.
Thank you. And then Hannes, the floor is yours.
I start with the HPKE. This time I wanted to provide a little bit of background. We had lots of discussions on the list, so I would like to have you follow along so you understand where we are and why we went such a complicated route. Okay, version 9. So just as a reminder, won't go into great detail of what each PKE does, but what is relevant to the subsequent slides is that there is an API described in a document. It's informational, but it's still an API. You don't have to implement it, but most implementations do. And one is one API command which we are using in the document, or which implementations use, is called seal base, which as described here, it's copied from the text, is it encrypts a plain text abbreviated with PT to a recipient's public key. Right? The whole thing is about public key encryption, so that's what it does. The sender has the public key of the recipient, but it generates its own ephemeral public key as part of this. And if you carefully look at the function signature, you will notice that it has two parameters besides the public key of the recipient and the plain text. It also has the AAD and the information field. And the information field, which is the one we are focusing on in the next few slides, is a parameter that influences the generation of keys. And if you look at the COSE specification for other public key encryption schemes like ephemeral static Diffie-Hellman, then you will notice that it also has something similar, just gives it a different name, but it's the same concept. It includes parameters about the context in which you're operating or the application is operating on. And it binds that context into the key derivation function. And why does it do so? It's because there are a number of different attacks. Some of them are very old, like the unknown key share attack, I think 94 or so. Others are more recent, different incarnations of that attack, like selfie attack and so on and so on. The other parameter, the AAD parameter, is something that then feeds into the actual encryption with the AAD algorithm, which I'm not going to talk about. It's not has never been so controversial, but the info parameter content has been controversial. That's why I focus on that one. So slicing that. Brian, is it something important to this one, or you just already want to, or you don't?
Yeah, I wanted the opportunity to yell at you about HPKE. No, actually, I was having trouble logging in, and I had a comment on the last presentation, and then I felt bad, and then I went up, but maybe it's totally.
I'm sure you will have a question anyway, so keep on.
I will. Yeah, maybe that's not helpful. Thank you.
Yeah. Okay. Noted. Yeah. Okay. So a little bit of history to explain on why we took certain steps, because COSE itself already made some precedents or created some background here. It was Jim who obviously was very much familiar with SB NIST Special Publication 800-56A, which talks about different key derivation functions and also talks about precisely this topic in one of the appendices on how that this context information, this info parameter, should be populated. It's a little bit vague words and makes pointers to various different academic publications. It doesn't give a precise suggestion of what you should include and also like what specific attacks are enabled. But of course, then there are these publications that give some of those details. And it then came up with the famous COSE KDF context structure, which you see on the screen, which contains a number of information, which is basically a COSE representation of what's in a NIST specification. And you can see, you see the identities of both parties. So this is the party U, party V, sort of context, weird terminology, but it has information about the algorithm ID It has information about the length of the algorithm, the key length, and so on, and a couple of other sort of additionally provided information. So you can, on top of this, you can put in more information. Of course, all application specific, and even the identities are obviously application specific. So the COSE RFC 9053 only talks about it at a very high level because it doesn't know what applications you're going to use COSE with. So it talks about roles, encoding roles like server and client, or application identities as, for example, if you use DNS names also. So interesting artifact is that COSE sort of dances around a little bit on where do these parameters come from, and basically says maybe out of band, and maybe they're carried in a message. For some of the parameters, there's special header fields to carry them. In other cases, like you kind of need to define elsewhere on where you take those parameters from. Keep that in mind for later. Okay, so then we started off with HPKE and created the first version. And so I reused the KDF context structure in doing so. And I came up with a sort of a mapping, a more precise profiling of what Jim put into the COSE RFC. The first person leaving already? No, John, I was just kidding, just kidding. We makes you. Yeah, so as you can see, like party U, party B, sort of I'm picking the information that is in the header in other parameters like the key ID, and basically depending on what structure you're using. For the algorithm IDs, it's funny enough that COSE didn't precisely specify where those algorithms ID come from, because as we will later see, or if you guys remember, the structure is actually nested. So there's not just one algorithm. So the question is like, are we talking about the key exchange algorithm here, or are we talking about the algorithm used for encrypting the actual content? Two algorithms. So it doesn't distinguish that in the text of the COSE document. And so I made a guess on what would be most useful here. And it turns out that that's also relevant, needless to say. That's the next presentation, actually. This is now cut a little bit, but I didn't want to go as far as mandating to use that structure. It's kind of more informational. Use that structure if you have nothing else to use, to provide at least a little bit of help to the developer in constructing this, because the developers obviously will struggle. And then we went on implementing this with Lawrence and Daisuke, and where's Daisuke? And others. So, and that was sort of a little bit, yeah, it was not as easy as we thought, because it crossed through different layers in the libraries. And so it was like a hassle to implement. And so our immediate reaction was, oh my God, developers will get this wrong. We had difficulties implementing it. So we stripped it out in version 2. So yeah, so we said, yeah, we simply said, and also interoperability wise, it was difficult. Because if you put something wrong in there, obviously nothing worked and you had no idea what was going on. And so we said, oh, it must use an empty info parameter. So of course, not quite like security wise, not quite the end of the story, which is why the slides continue. Because later, next version, we added it back again, because we realized that's also not the story. And we said, you may want to use this, or we're also a little bit lukewarm about what developers should really be doing, because we didn't know ourselves. So we did interrupt testing again. And of course, we ran into problems. So we enhanced the language to make it a little bit better, and said, like, if you don't know what to put in there, then the value defaults to zero-length strings, because specifically for interrupt testing, we didn't have that application context. And so we didn't know what to put in there. And if you ran two implementations, it was guaranteed to be wrong, right? So a little bit of problem. So version 4, back again, a little bit more text. Then going forward, lots of discussions on the list. We published at the last IETF meeting, we totally changed the design. Because then we thought, okay, maybe we shouldn't rely on out-of-band data. We should actually only focus on what's in the message and just compute. We don't actually use we create a new structure, a simpler structure than before, and we call it the recipient structure. And that only contains a few fields, namely, we already tried to address the issue that we found, and as I will talk about it at the next presentation, the security problems. We we clarified what the algorithm information actually refers to. So we're not including the algorithm information of the key exchange algorithm here, but instead the content encryption algorithm. So we took note of that, but of course it then only fixes it for HBK and for none of the other variants. And we included, since we assumed that the developer would then include all these parameters into the protected header of the recipient structure, we kind of, we could, or the idea was to make use of that and then to fold it in there. We already have an encoding structure for that for this protected header in the recipient structure, but it requires you to carry everything in there proper, like more or less replicating some of the fields. But it also then raises the question of like, what happens if you have a key ID or some other identifying information in the header or in the application context, and then there's a different identifier in that structure? Like, you may be believing that you're actually doing the correct authentication, but someone just, like, you can get all sorts of things wrong if you convey information twice. A detail which we haven't figured out yet, so a problem. And then we looked at, we are not the first ones looking at this. How do others really deal with this? And so we looked at LAMPS for some inspiration. And it turns out that they have, there's one specific document that discusses chems, and HBK is a chem. There's a recent publication, RFC 9629. And it has a similar structure, of course, encoded in ASM1. And you see it on the screen, a screenshot here. And it, of course, also has the algorithm identifier. It also has the key length. And then it has some, application provides it, we don't worry about it issue, but it doesn't talk about many of the other things. It basically glances over most of the aspects we've been talking about, like where do the identities of the parties come from. It basically leaves everything out and says, basically copied from the RFC, the UKM, which is this user provided keying material, can be a nonce, it could be identifiers and so on. So I think that's a nice, convenient way as a specification also to just punt on the issue and then let the developers deal with it, and they will then read the NIST specification and figure out what the right value they put in there. They define a structure and everything will be great. And I'm not sure that's the right approach either, but the LAMPS group are quite happy with that. I'm almost certain that people will get this wrong and we'll hear from them again. So another update. That RFC is an update to another RFC. But of course, we discussed this extensively. We also discussed it at the last IETF meeting. We discussed it on the mailing list. Here's a thread, most recent one. Got a lot of input. And I thought that Sophie, it's too bad that she's not here. Conflict with the TLS mailing, with the TLS meeting, I guess. She has an interesting take on it, which I like. And here's what she says. She says, I shouldn't look over there. You cannot trust the information in the headers with the qualification that except for the ID, which is the key ID, which references the key that you are supposed to be using, because ultimately you need that information somehow, because otherwise, like, out of all the keys, what are you supposed to do? Trial decryption or that trial steps. So, but even that has some specific issues which he documented in a blog post. You can read up all on. You can read up on the mailing list thread on this. But the interesting thing is the key ID is the optional parameter in the COSE specification, And the algorithm information is one that is typically used in all the, like if you look at all the examples and all the text that RFC doesn't says you must use it, it just basically assumes you use it all the time, and it drives the whole machinery on how you do everything. But practically, since if you don't rely on the parameters in the field, or in the message itself, it needs to come from somewhere else. So there has to be some structure where you draw that information or take that information from. The COSE key, if that's the distributed structure you use in your system, that would be a nice way to do these type of things, but it's not powerful enough to express that type of information. So there would be somewhere you would get that information from. And I think most of the implementations don't do it that way. I think it would be interesting if we go around and look at the different implementations, figuring out on how they actually do this. How easy is it for developers to really configure it in a way that if I send a message to Brian, have a key ID in there and not the other stuff that I've shown on the previous slides. How easy is it to construct sort of the payload to then securely do the processing? I would be interested to see how that sort of really works across the libraries. And I have my doubts that it will be of high quality. Because like if we have a hard time figuring out and discuss this for extended period of time, it's quite likely that developers also will not spend a year thinking about it. They would just do something what is most convenient to them.
I also have my doubts that any message you send me would be of high quality.
I think that's why the node well is there. You guys, yeah. When you said it's a civilized group, then I was take that back.
It's civilized, but with a little modicum of snark.
Okay,
carry on.
Yeah. So, long story short, is that I think what we have in the current document, the current approach, is not good either. I think it's
Sorry, I'm the chair. I shouldn't laugh.
Yeah. We have to rely on some of that information to be available out of band, and basically utilize that instead of munching everything in a message. And then attackers, all of the information I'm sending to you in these headers is essentially up for the attacker to manipulate and play around with. And you cannot trust that information. Like there's so many things that can go wrong, so many attacks. We cannot be certain that there's next time there's another clever person sort of figuring out another attack, like munching different protocols together, using different, like there were already many attacks. So that's my take on it. But I also acknowledge that even among the authors, there are different views, let alone the working group. So it's a little bit tricky. And so, yeah, I wish we had more cryptographers in the group we could reach out to. Maybe we could still give it a try to reach out to, like, find some cryptographers. Sophie is a cryptographer, but maybe we can also reach out to others to get some additional opinion. I think that would give me more confidence, but unfortunately, this is not just the COSE HPKE issue. It's a little bit larger than that.
Not as chair, I will note that in the Jose HPKE discussion, Sophie spoke up essentially extolling the virtues of HPKE, and Deidre also spoke up with characteristics that the specification should have. So both of them seem like likely victims who are cryptographers that you could reach out to.
Well, yeah, they had expressed their opinion about this, so they are basically along those lines. But I fear, like, if I go through, let's say, if I go through and assume that algorithm is not being sent, I think most, if not all, implementations will fall apart because they just drive the whole machinery out of that algorithm information. So they wouldn't do a dip into, they wouldn't start with a key ID lookup, which is optional, And then there are all sorts of different ways to do the key ID. It's not that just that we have one field for the key ID. That's another document I've written, because that's another problem, another problem for another day. And so that it's a little bit tricky. Carsten, you see that I'm struggling a little bit? No.
Yeah, so I hear you saying that we don't have the information in the COSE key. And why is that so? The COSE key is a structure that has a registry for the things that you can put in there. So if there's something that we want to put in there, we can put it in there.
Yeah. So for example, so COSE key is great. So assuming, so my ambition level was that I configure both parties, if it's two parties, I configure them with a COSE key, which has a key ID in there and algorithm information. And then if I send you a message, if you get that message and look at the key ID, you know what you're supposed to be doing, because you just look at that kind of entry. However, so there's an algorithm field, for example, but that algorithm field doesn't take into account that we are actually using a layer structure here. It doesn't say,
Yeah,
oh, I'm
let's do a
using a
better
key exchange algorithm with that, and I could actually have, let's say, AES key wrap, but I allow that to be used with content encryption algorithm with AES, GCM, and CCM, for example.
Yeah,
Could I express?
So just do a better algorithm field.
Oh, that's another topic. So this goes back to the fully qualified algorithm stuff.
No, you just said you have several of them,
Mhm.
and why don't you put all of them in there?
You mean I would just list multiple entries of, and then, or how would I do
Well,
that?
just include information in the key that allows you to safely use it.
Mhm.
And if that is more than a single algorithm identifier, then be it so.
So for example, are you suggesting that I would put the key exchange algorithm, let's say, like the whole string did HBKE, and I would then put additionally the content algorithm identifier appended to it? Or I don't know, just making
Two
this up
different
here.
fields.
Different fields. You would have two fields, the algorithm, and one for the HBKE and one for the content encryption algorithm.
So
identifier?
I think we have to be careful with these identifiers, because
Yep.
sometimes we use these identifiers to do some form of negotiation or lookup
Mhm.
and so on. That's when it's important that they are very specific.
Yep.
But sometimes we also use it to check something, to make sure that a certain situation is the one that was intended and not the one cooked up by an
Yep.
attacker. And if we try to have one thing both, we're probably going to hurt one of them. So fully specified, great for negotiation and lookup, but maybe not the best way to actually guide an implementation of what's supposed to do with this information.
I think we need to take a look at that again, to the COSE key and how to actually get this fully working. So if we could work together, that would be fantastic. I think there's some, it's not just like, I don't think all the pieces are there. That's what I'm going to do.
So as an individual, again, to the extent that we're sprinkling information throughout the structures, we can obviously choose to do that, but I would want to understand why each piece of information is being sprinkled into the structures and what attacks it's intended to mitigate.
Yeah, that is a challenge, because it requires a lot of reading. It's just there's, like, even the publications are not, they are a little bit hand wavy on certain parts, I have to admit. I read through them. It's not as easy, like if you omit this field, then that attack will happen. But sometimes it's very, like, the good thing is these attacks are not simple. It's like not the alg equals none type of attack, but this is a different type of level of attack. But still, these attacks exist, so you can do them.
Sure, but as Deidre said in PQUIP,
Mm.
whether we want it to be or not, to the extent that we're using cryptographic algorithms and data structures, we're doing cryptography.
Yeah.
And there's an onus to either understand it or to consult the experts to the extent that they say you're not screwing up.
Right. Well, I think one reason why it took us so long to get this discussion moving forward was that it took us a long time to read through the literature, because there's a lot of history around this.
Understood.
So we can summarize that for sure. So will definitely help. Okay, do I have something else? No. I switch to the next presentation. So if anyone has like is passionate about these type of things or has an opinion, ever always wanted to look into key derivation functions, I see smile and almost laughter. But you, Renzo.
Yes, long time ago I wrote a paper and I needed to do some key establishment and I used the COSE key. And at the time, yeah, it was new and I had to add some. I knew everything was not there, but in the end I managed to do it. So I think we should reuse the COSE key structure.
Mm-hmm. Okay.
Maybe
Cool.
it's missing something, but we already have it. So
Mm-hmm.
yeah.
Yeah,
yes,
very
but we all should agree.
Yeah,
on the things.
Send me the link to the paper.
Okay.
Yeah,
maybe
yeah.
I don't think I've
put
read
that
it.
on list, and to the
Or
extent
to
that
the
you
list.
think
Cool, thanks. Really
any
appreciate it.
extension is needed, please say what that is and why.
So this is an extremely short one. So since we already had the COSE meeting, I would like to avoid repeating myself because there is a group of people who believe that we should only do post-quantum crypto and not go into hybrid. If you are part of that camp, ignore that presentation. There's another camp who believes HPKE is not a good mechanism. Ignore that talk. If you are of the opinion that all this post-quantum crypto is just some fancy nonsense, then and the security problems are elsewhere, then ignore that talk as well. That hopefully should still leave some people in the room. So this is referring to my previous presentation. In that HPKE specification for COSE, we list or register a number of algorithm identifiers, fully specified, referring to Mike's presentation. And we include sort of the classic HPKE algorithms, like this is sort of elliptic curve cryptography. We initially had algorithms in there that were from the category of these hybrid chems, which we then said, oh, this is premature. We shouldn't do that. We should move them. We should tackle with them later. And this led to the publication of this document. And I show you what the content is. This is the content. The document takes an existing algorithm registration and just registers those algorithms. The X25519 MLChem 7068 with COSE HPKE. And then, of course, adds like security considerations and all that other stuff to it. But that's essentially like there are two algorithm registrations in there based on what has been proposed with HPKE. It will take a little bit longer because it obviously depends on the specification of these algorithms for use with HPKE in order to have them be used in here. So it's a super simple document. And yeah, that's what it does. Yeah.
Why were those particular algorithms chosen?
Because the authors thought of those documents thought that those would be good algorithms. And they probably took it from some modernist specification. Or no, actually didn't took it from this specification. They took it from some other working TLS, I believe. This is Deirdre published those.
Do people want to speak For or in favor of working group adoption?
Deidre thinks it's great.
But she's not here.
Yeah, she's in DLS. She's the chair.
Shucks.
Brian, you're going to implement this? But you're not implementing anything.
Who has read the draft?
But there's not much to read. There's a registry.
Who has read the draft?
I see 2 people.
2.
Yeah.
Okay, we don't have enough information to make a call on
Yeah.
this.
Who has read here any BQC drafts?
I
That's
will.
there's 2 more, not counting their chair.
Right.
Who read everything.
I will say that following the meeting, we can ask the
Yeah.
question on list.
Good. Yeah. Next slide.
So next presentation.
Next deck.
Next deck. I mean.
Take a deep breath.
Okay. So in my earlier presentation, I was referring to some problems when you are not including the algorithm information into the key derivation function. And there we have a specific attack. So I'm telling you, like, there's an attack, we should do something about it. And maybe you find that as a good argument to actually work on it. And the description mirrors the approach that the LAMPS group does, because the attack is also applicable to CMS. And it's with my co-authors Russ and Ken. Russ, because he basically stole the text from his document, which he has in LAMPS, and Ken found the attack. Okay, so the attack is, if you remember, this is the slide deck I presented at the last IETF meeting and just updated it. The attack is, if an attacker changes the algorithm identifier from an AAD algorithm to a non-AAD algorithm, he can recover the plain text. That's not good, right? And because, of course, it only works if he can do that. If you don't have information on the recipient side, like what key am I using in the communication with a specific other partner. So that's what I was tying back to what I was previously referring to. So and this works in all of these. This is not just a HPKE specific thing. It's actually not at all. It has nothing to do with HPKE. It works with all the other key exchange mechanisms as well. So that's what I told you, and also the copying from the LAMPS document, which you see here, has the same name. In the latest draft submission, we tried to make it a little bit more colorful in some sense. Ken added a bunch of pictures to illustrate like the different key exchange mechanisms that we have in COSE and how the layer this fits in, and sort of the box that you see in the middle, the big box, the KEK prime, that is what this document does. It basically makes another key derivation to produce the KEK prime out of the KEK that was produced by these key exchange mechanism, whether that is COSE HB key, ACDH AS key wrap, or the other versions of key wrap, or other versions of ESDH, etc., etc. And also combines in the algorithm information of the content encryption algorithm, not the algorithm for the key exchange mechanism. Remember the 2 different algorithms? And that then produces, obviously, a different key. And if someone manipulates that information, then obviously the decryption will not work. Then you will have a different key. And yeah. So it's a generic mechanism to mitigate that type of attack. In the HPKE case, we have other possibilities, so we could do something different, and then we don't have to sort of use this mechanism. But I think we don't want to rework all of the other stuff or at least I've, will take a little bit of time to change those as well. So that's a little bit of repetition of what I said last time, but I think it's, I think we have to do something here, at least point out that there are problems, unfortunately. Sorry. Yeah. I feel guilty to have contributed to those problems. Oops. But
Well, to the extent that we allowed non-AEAD algorithms, we all contributed as a working group.
I'm not saying anything further to that.
Who has read the draft?
Do you guys read anything? I need to produce TikTok videos, I guess. Really? I should do that. Oh. It's Friday, right?
Okay. Given the answer is 0, can I get a couple volunteers to read the draft?
That would be great. Yeah.
Please say your name or put it into the chat for the minutes.
Or
Come to the microphone.
Say, so the meeting minute takers. Who's actually minute taker? Oh,
Gaëtan Fege.
okay.
I'll put it in the chat as well.
Okay.
Thank you.
There was someone else.
Do we have a second volunteer?
Benzo.
Okay.
Okay. Brian, did you raise your hand now?
Yeah. I can read it.
Awesome.
I can't read, so I'm not going to volunteer to do that. I was having trouble finding the little hand things.
Clicker.
Just, I'm a bit of a tourist, so following along. This problem was introduced through the introduction of non-AEAD algorithms into the content encryption algorithms, right?
Yep.
And your draft here is proposing basically shoving a new KDF layer in the middle of processing to all algorithms.
You can use it with all algorithms. So if you don't use any non-AAD algorithms,
you wouldn't have to.
You don't have to do anything.
But in order to interoperate and use this, you would have to have support for it and indicate support for it on both sides. I mean,
but it's it depends a little bit on the application you're using this with. So I wish, like, had we figured this out earlier, like that DAC, it was an unfortunate timing. So obviously, when we worked on that, we thought that there would be no problem at all. And otherwise, we would have included that content into the other document, into the whatever the name of that document was, where we introduced CTR and CBC.
The straight CBC stuff.
Right, which was a Russ Housley document.
There were just
but the DAC
remembering there were a lot of people that said don't do this at the time, including the cryptographers that you've been.
Now I'm listening to those cryptographers.
So we all learned.
But the funny thing is, the cryptographers also say the practice we have today is not good. It has problems. And like that was the previous presentation, the first presentation I gave. And
about putting content in there.
But like this is a specific instant of context information, and like who knows whether there are other possibilities now. This is a specific attack, a downgrading attack from AAD to non-AAD. Maybe there are other attacks that are possible by just still changing the algorithm from AES GCM to CCM. I don't know. So it's probably left as an exercise for you to find the next attack if you play around with the algorithms. There have been attacks where people switched from a key exchange algorithm based on public key crypto to HMAC, to an HMAC-based algorithm. Crazy, because the key was suddenly interpreted as a symmetric key.
The one in Jose?
It was, I think it was
that happened in Jose.
Yeah, but that's,
we covered that in the BCP because that had happened in practice.
Yeah. So
but these are exactly the things that you wouldn't expect, right?
But that's not actually the same as this. But
no. I'm just giving sort of like It's
that was a
sometimes
key
innovative
exchange.
attacks.
Yeah.
Well, the key exchange is like
That's
here is
that was a
tightly
signature
integrated.
problem, and I'm
Yeah.
mistaking for the type and context of the key, and then
Fair
I mean,
enough.
it's same
Fair enough.
general classification, but actually really, really different than this stuff. Anyway, I'm just trying.
Depends on how you see it.
Yeah, I see it, I guess, differently than
Yeah,
you.
that's okay. That's okay.
I guess I'm trying to wrap my head around, like, you're introducing a new KDF layer to COSE encryption across the board. That's really at the COSE layer, COSE encryption layer, not at individual algorithm layers. That would be independently specified.
I'm introducing. What do you mean by independently specified? It's like there's an indication to use that one.
Yeah, that you do.
Yeah, ideally that would be something that would also go into the COSE key structure because you want to signal it out of band. You don't want to signal it in there because then you allow the attacker to turn it off
Same
again.
thing, yeah.
In my opinion, that's my opinion. The LAMPS people think of it differently, but okay. Because the problem is if you have CBC and CTR, there you don't have, like, that's why it's a non-AED cipher. There's no integrity protection over the thing. Whatever you put into the header is not basically is free for all, right? So, so it's a little subtle.
Brian, could you make your
have a review?
Could you make your observation about it being a general purpose functionality being added on list, please?
Oh.
You don't have to read the draft to say that. You've already said it. I just
sounds like sure. I'll try.
So, what is your concern?
I don't have one exactly. Okay. So, unless I was trying to understand, I guess, before I shared my concern, and now I'm not sure I do. So, I'll try to research and make sure I can at least say something competent before I say it.
Will take a while, I can tell you.
Right.
Not because
being competent.
No,
yes, it will take a long time.
No, I mean, don't not well again. But if you like we had this discussion in the group of authors, and everyone said exactly what Mike said. Oh, we need to look at what the different attacks are, and then people said, oh, we just need to look at that NIST specification. And NIST specification says, oh, there are these 10 references. Oh, just read these 10, and then there are 10 more, right? And it's sort of like, woo, you suddenly find yourself reading several months, right?
we still have people in the queue. Cedric.
Yes, so I haven't read the details yet, sorry, but from the description, it was not super clear that including the encryption type or encryption algorithm was sufficient to discriminate between all the different use cases and branches that were coming into it. So I'm wondering if this actually covers all the these different cases and also covers future cases where you introduce a new way of using key derivation in the process. Why is I'm all for adding stuff into the context that is patched to the KDF, but the choice of passing just that identifier and nothing else is a bit surprising if you look at other protocol design elsewhere. Typically, you put all of your context in there, not just definition of an algorithm. So because it's a big change that's going to affect all users, if you want it to be consistent, all paths, if you want it to be consistently applied. I'm wondering whether we should look for positive proof that we are distinguishing all the paths as opposed to looking for the next attack.
The audio was a little bad in the front of here with a lot of echo, but I think I heard you say, like, why just include the algorithm information and not the rest, and not everything. And that's I think that's where the relationship a little bit is with the initial presentation I gave, where we are essentially designing a new key exchange algorithm, and the latest presentation. It depends on our ambition level. If we want to just fix the use cases or the problems related to the non-AAD cipher and that specific attack for what we recently introduced, that document will do the job as it does the job for the CMS guys. In future designs, like we do for HPKE, we need to ask ourselves a much broader question, and that's what was the entire first presentation was exactly about that topic, and there we are doing that. Should we then make some recommendations for other key exchange mechanisms? It depends a little bit on the outcome of that conversation, but I would then say most likely yes, we should also make some recommendation, maybe revising the COSE RFCs to actually clean up some of that stuff, because there are many different key exchange mechanisms, and there was a lot of uncertainty on how to use some of this. We need to sort of take that into account. Maybe I don't know what the right approach is. Is it an errata? Is it information or a document that, like other documents that were already published, that provide some additional guidance, security guidance, or is it a revision of the specification? I don't know what the right approach is, but we need to finish the conversation and the discussion on that first before we jump to the conclusion about like what's the document management approach to this.
Okay, so before we would ask for adoption, I would want to see several people that had read the draft describing their views on it on list. And we do have at least 2 people who volunteered to
Is
do
there
that.
someone else who like works on the cryptographic algorithms and
Peter,
Peter said Peter wants to do it?
I'm volunteering to
Oh,
read
Peter.
it.
Okay.
Yeah, this Peter. I'm volunteering to read it. That's
Awesome.
oh, thank you,
Awesome. Okay.
Peter.
Yeah.
Lawrence, and then we should probably go on.
Yeah, this is about the, I'm just trying to, this is about the draft with the additional KDF layer, right? I'm mixed up with the streams here, right?
Yep. Yep.
Yeah, so I find that, I kind of oppose that draft. I think that there's more elegant solutions than wedging another KDF layer in. I think it's unnecessary. I think the next algorithm solutions are better, and I don't know. I guess we have stopped discussing those or something, but
we can definitely discuss this. But this is at least something that the cryptographers who found the initial attack in LAMS thought is a good solution, and that's why there's a document in the LAMS working group on if you can find a better approach, we should do it.
yeah, I think your solution, this solution does solve the problem, but I think it is wasteful, and I think just locking down the next algorithm is better, and that's what's kind of in the current COSE HPKE draft already, I think, right?
But that approach, unfortunately, we need to look at that, doesn't work, because it's not, we would have to modify all the existing, like we need to specify, we need to feed that information into somewhere. Like in COSE HPKE, we have the opportunity to modify, to decide how the key exchange mechanism works. While for the other ones, like what is all the stuff that is defined in the COSE spec, we can't change that. How do we do that?
Well, you're changing it by putting a KDF layer in already, so you're
No,
changing it.
I have a KDF layer following after what the output of those algorithms
But it's
is.
not interoperable.
It's
effectively
by
a
design.
change.
By design, it's not interoperable because
right.
You
So
know, like,
if you're making a non-interoperable change, why do it by wedging an extra KDF layer when you can do it other ways?
the other approach would be to modify, to update the COSE RFC.
Yeah, that's right.
That's what you're
And
proposing?
That's what I think should be done. Yeah, I mean it doesn't matter one way or the other. You're making a non-interoperable change. It's going to be new algorithm IDs or new implementations on the sender and the receiver. So I mean.
I will note that at the beginning of the discussion of this, it was pointed out that you only need this if you're ever going to use a non-AEAD algorithm. If you've locked down your system to not accept that, this attack isn't pertinent.
Yeah,
And
agreed.
so in which case you wouldn't have to rev COSE.
Yeah.
Yeah, we should definitely think about the document management as well. So where we
Okay.
put the text in there, is it separate document? Is it a revision of an existing document? It's also a question for the chairs, not necessarily for me. Okay, but
I think we should continue to consider this as an individual draft with those of you reviewing it for now. Thank you.
Okay, next is the marker mounting right proofs.
Hello?
Hello, you should have the right to share your slides now.
Lovely. And I think I'd like to try controlling the slides from my end, if that's okay.
Yeah.
Hello, everybody. Yeah, I'm from Data Trails as well. I'm here to introduce COSE Merkle Mountain Range Proofs, which is a draft that establishes a verifiable data structure in alignment with the registration requirements of the COSE receipts document from Ori Steele. So let's get on with it. So a little bit of context. Last year, part of the work at Data Trails, we rebuilt our transparency layer and we went looking for a new verifiable data structure. We looked at loads of things and we had some specific properties that we were looking for. We wanted the data structure to be fast for appends. We wanted coordination-free writers that were easy to update and could add to the log as fast as possible. We wanted a really good story for replication of the logs to people who were interested in auditing and monitoring the data. And we also wanted a really simple story for operations teams that were retiring old data that was no longer interesting, pruning of historic data, such that it wouldn't complicate verification of future data in the log. So we had a look around, and Merkle Mountain Ranges, which is the popular name for the thing that we chose, seemed like a great fit. It had all of the advantages on the left, plus some cool extras. We found quite a lot of implementations in various places that had minor differences that seemed to us to be pretty arbitrary and sadly no standard. Being involved in the IETF stuff through John and Steve Lasker, we quite quickly saw COSE Receipts as a great vehicle to surface the advantages of this approach through. Particularly the unprotected header bag is a great way to surface the advantage of being able to pre-sign the receipts, which you get with this approach. COSE Receipts, I think most of this room are familiar with it. It's the draft by Ori Steele, which establishes a registry for verifiable data structures, and which I think requires a draft in order to be registered in that document. I could have that wrong. So what are Merkle Mountain Ranges? Well, it's a popular name for a structure that crops up in quite a lot of places, known as post-order traversal tree, history trees, binary numeral trees, just to pluck a few names out of the air. They're also cited in the original, the oft-cited paper from Crosby Wallach with the specific advantages of the storage layout pointed at. Other things, they're really good for the optimistic concurrency model that I mentioned, linear storage layout, which is really gives a lot of simplicities for managing the data. They're easy to prune, and the structure allows you to pre-sign your receipts, which is particularly handy. There's a more formal definition of the properties of this algorithm, the structure, in a paper by Lena Dreisen and Sophia Yakubov, which is available in an ePrint for anybody that wants to follow up the detail on that. So that's the big picture. If we're encoding this according to COSE Receipts, then we end up with a protected header with the the algorithm identifier, the VDS label that we're requesting is 2, and then the receipts are then encoded in the unprotected header as a list of inclusion proofs. The inclusion proofs are a list of inclusion proofs in one receipt, and each inclusion proof is itself an index identifying any node in the MMR and the regular Merkle tree inclusion proof. Because a notable difference with the structure is that instead of every state of the tree having a single root and therefore a unique receipt, receipts are rooted at the peaks, which change less and less often as the tree grows, and that's the property that allows us to pre-sign the receipts and gives us some of the advantage that we get from this approach, which include being able to offline assemble receipts if you're a relying party. So a receipt of consistency, largely because the receipts of inclusion allow proving an interior node. I've specified the proof of consistency as inclusion proofs of the interior of the peak nodes from the old tree size. So you essentially just get to reuse the same code. A nice property of the way COSE receipts represents the consistency proofs is they specify them as a list of consistency proofs. And in this case, we've been able to leverage that so that you can package up a catch-up proof for the whole tree state if you've been offline a long while into one receipt bundle. So a little bit of a visualization for what the nodes in a Merkle tree look like, and a chance for me to read out quite a lot of bullet points. So on the screen, the blue nodes are for tree size 11, and the green nodes are the tree having grown to tree size 16. The accumulator that is defined in that paper that I mentioned earlier for the blue tree is comprised of nodes 6, 9, and 8. The inclusion proofs for the first 3 leaf entries, not 1, 3, and 4, are rooted at peak 6. As the tree evolves, the log checkpoints are all signed peak lists or accumulator states. And you can see that a single receipt for not 1, 3, and 4 can be pre-signed as soon as you have element 6 in the accumulator. And as the tree evolves, that peak may eventually get buried, but it remains in the inclusion path of all the future receipts. So the draft storage layout is not in the scope of the draft that I'm proposing, except that there's a very narrow interface defined for the algorithms that need to add to the storage and to get elements from it. And I've just acknowledged that tiling in a linear sense is a very convenient way to work with that on this slide. And you get this nice property if you, at the start of each tile, you retain the accumulator from the previous log state at the beginning of the tile, then you've got a completely self-contained lump of data for any inclusion proof for any element in that tile. And that's just a nice thing that we get from that. Notable in the draft is that because we are constraining the tree height to 64, then we always know that the ancestor peak list is, it's never going to be huge, and a peak height of a tree height of 64 is an enormous tree. So there are, this last slide is just acknowledging that there are a lot of implementations out there in the wild. The implementation section of the proposed draft doesn't have them all, but it's got quite a few. We've also got at Data Trails, the production service has a Golang implementation that's all open source and available. I did a TypeScript implementation for comparison with a thing that Ori Steele did recently was do the Sunlight Tiles API from Certificate Transparency, which is a slightly different layout. I made a TypeScript implementation of this approach so that they could be compared and contrasted for their differences. And then the algorithms itself, which some of which are included in the draft, are written in Python, and there are test vector based test cases and generators for them in that last link there. And then, being somewhat new to the draft process, probably quite a lot of things that I haven't thought to include, but notably we haven't done hash algorithm agility. We've just defined this currently for SHA-256. Of the implementations that we covered, there were a lot of hash algorithms used by the different implementers, Blake, Peterson, SHA-3, Ketchat, there were more. And as I mentioned a minute ago, we have test vectors. They're not in line in the draft, but they are in the repository, and we'd be expecting to add those back in before it was complete. A production implementation of a transparency service using this approach would need more algorithms that are in the draft. The draft simply specifies production of the proofs and verification of the proofs and no more. But if you're actually maintaining an actual service, then there are other algorithms which would be considered not be considered essential, but which are not essential for this draft. So maybe we need to add those back in or have them available in some supplemental material. So yeah, so the essence of this is it's a draft that defines a COSE receipts verifiable data structure, and we think it's worthwhile as a specification, if not appropriate as a draft, and we'd like to hear your thoughts on that. That's it.
Yes, John.
So thanks, Robin. For folks who haven't necessarily kept up with the receipts work in particular, the next presentation is going to be another one of these, talking about a related thing. So there's a point of process that is interesting for me here. The next one has been written up as a profile of an earlier document. This one's been written as an individual draft. Whichever side of that fence we fall, I think they should be the same. And probably all things being equal, I think this one, well, both of them should be profiles of the receipts which already established a registry, rather than individual full documents, but just for people to consider when reviewing them.
Yeah. Thank you, John.
Who has read the draft? The usual question.
Just say it on mic, please.
So I have John Gita, and also I don't like to drop people in it, but we've had a review from Cedric Fournay. So if Cedric wants to officially own up to that, that would be helpful as well. So it's had some review, but could definitely do with some more. We'd like to get it adopted and ideally put in at the same time as this CCF profile that's going to be presented next. So if reviewers want to get a bit of a 2-for-1, do them both at the same time.
Do we have volunteers to review the draft? Say your name on mic or put it in the chat.
Yogesh Deshpande.
Okay. Cedric?
Yes, I can also review it formally. I already provided feedback, but I can review it more formally again.
Thank you. Thank you very much, Cedric.
Thank you. Okay, well, I guess if there are no other questions and comments, we will move to our final presentation. Hank, floor is yours.
And just procedurally, I think this draft is in the same state as Hannah's last draft, that we want to see some reviews on list before we make any adoption decisions.
Okay, this is the next one I see.
Here's the magic wand.
Thank you, Mike, for the magic wand. Yeah, hi, I'm Hank. This is the last presentation, I think, scheduled for the session on a Friday. Okay, this is adding a SCID to an existing framework that is a e-notary, the confidential consortium framework. I'm speaking on behalf of all the authors here. Quickly, CCF, expanded, that is the confidential consortium framework as open source software. In this case, there are a lot of features that are not required by the SCID architecture, for example. We have here multiple of these e-notary nodes. They are all replicas. There's a primary one. And we have therefore a centralized execution, the primary. All of these nodes rely on some types of rats. So there is trustworthiness evidence and attestation results as correspondingly because we're using TEEs to run the central notarization functions. Each of these replicas has their own principal governor, so to speak. Therefore, governance is also decentralized because it's a multiple pair of eyes systems. If something goes wrong, there's a consensus protocol running between the automated parts, and there is something that has to be checked by governance if you change policy. So all these are safeguards to handle this whole system in a more secure way, and therefore increase trustworthiness assurances. So that's a little bit background about the CCF part. Features, basically a little bit redundant here to what I just said. Again, remote attestation on the nodes. You can scale nodes up to what you need. It can be a resource requirement that you must have as many nodes because you're busy, or you just want to be very resilient. Proposed would apply model. That's what I said about the primary governor of one of the replicas. And yeah, basically all of these are pretty obvious, I think. There are multiple implementations in several languages. Primarily, I think that is C# and JavaScript. All of this is open source, available on GitHub. The basic principle, I actually don't really want to walk too fast through this. It's a binary Merkle tree, obviously. So the VDS that is used here is pretty well known. There is a key value store co-located. And in this TEE that actually handle the ledger operations, there's always one key value item that goes current, that's processed, but there's also, of course, a key value store. And the ledger works in a certain proof way. This graphic would be more interesting later on. I think there's one detail here that's very interesting, that we can have a selective disclosure of these key values. That's a specific feature that comes with the open source software here. Next slide says all the links. So these are not, you can't photo this, but the slides, of course, are on the data tracker. I think it's documented well. The underlying crypto is based on papers, pretty recent, and the technical documentation is pretty exhaustive, to be honest. So that's all there, but this is an existing system that has not used COSE yet, and basically is a proof of concept that SCID can be added to any existing transparency service. So I'm calling it a transparency service right now. The commercial version of this framework is run by Microsoft on the Azure Confidential Ledger product. Again, there's a link here. The concept of receipts, or something very, very similar to the receipts as defined by the COSE receipts here in the IETF, is already available on the servers also. And this Azure Confidential Ledger will become Azure Transparency Service as soon as SCID takes over, so to speak. SCID will be added to it, and you will get a COSE receipt. You will have all the, I think, options, I want to say, and all the interaction options that are demonstrated by the Scrappy API already. And of course, a VDS interoperable COSE receipt. There's a gated preview plan for next year. That's pretty, I want to say, exciting for most people involved on that part. Quickly going to the CDDL that is associated with this profile of COSE receipt. This is all pretty standard. It's inclusion proof. You go through the whole tree. You basically start with one leaf. You have a path. You sign the thing. That's a standard COSE receipt. I think there's nothing new to this, except that CCF comes, of course, with some properties that are not specified here in the IETF, and therefore this CCF leaf looks a little bit different than just a hash of the new signed statement. And just go really quickly into this. There's a lot of documentation here, but to give example how I want to say existing solution data can be added to a standard COSE receipt, we expanded the leaf type. And in this case, I can give 2 examples. There are multiple uses for them. They can be concatenated, but most prominently, the internal transaction hash, for example, can reflect the client authentication and therefore the success and context. That's one, I think, very skit-ish thing that is interesting to users of transparency services. And I was talking about TEs and replicas. So the state of the whole system can be represented in a CCF-specific string value. That's the internal evidence called here. So these are additional information that are specific to the CCF specification. It's all well documented, but not specified by the profile itself, yeah, but referenced in the end. And that's basically all it is. So this is the first profile, and I heard maybe all of them should be profiles of the COSE receipt, so we could talk about how to make this more homogeneous in the layout. I think that's good working group work, so to speak. And that's why my question is this a good state to adopt it? The running code is there. Omri is pretty confident that it's working well. Well, we'll see in April, I assume. but for the specification itself, yeah, we would need a few more eyes. Maybe the volunteers that will review the mountain range might have same time a look at this idea. It's pretty concise. You saw the 2 pieces of CDDL. The rest is basically frosting around what the context is and why this is a profile for Skit. And this slide says in-room hands call, but we already had a good reading about who is willing to volunteer. So my question to the chairs is, could we repeat that review volunteer question here right now?
Yeah. Who would volunteer to review this document? Okay. So John.
And we added a John. Yeah, which makes sense.
Please put your names in the chat.
Thank you.
Thank you so much. Yeah, and then I think the same path as with mountain range is a very excellent idea. This shows how this works in principle, and therefore could be repeated over and over again with other VDS and other proofs, for example, because this is, I want to say, only the inclusion proofs, but there are others. If you come back to a service, you might want to have a consistency proof and see if the whole system is actually still the systems you want to talk to, for example. So yeah, this is my slide deck, and also Giri is in the queue. And here, geez, hi. Okay.
Yeah, just a simple question. CCF is supposed to be based on web transactions, the way I understand it. Why are you proposing this as a COSE rather than a HOSE data structure?
Because we are using Skit.
Okay.
And Skit mandates the use of COSE for global interoperability authenticity proofs.
Okay, so is that going to be an issue in the CCF context?
Absolutely not. Because that's the point. All the validation and signing is done on the outer layer of the receipts and the signed statements. The content can be whatever you want. You can put your JSON documents or whatever it is inside this COSE authenticity parts. So no, it's not an issue at all. It's just a universal change to an interoperable choice. That is the only hard choice we had to make. We had to make is how to do the signing and the receipt stuff. And we chose in Skit to choose COSE here. That is why this is COSE. And it is not a problem because it's an add-on.
Yeah, what you said, universal interoperable change.
Yeah.
And so I'm talking about the existing CCF infrastructure that's already based on web-based transport.
You can do one thing and also not do the other. So the Skit interface will be exposed.
Mm-hmm.
And I assume, but Amaury might have more information on setting here on the deprecation of other services. But of course, there will be a transition range. You can't just take away the thing other people rely on for years. But that is no problem in this case. And is someone else on the queue?
Okay, understood. Thank you.
Sure. Maybe, yeah, because Cedric might have to say something about that.
Yeah, just to amplify on that. So so CCF is an existing framework. It has been around for 5 years, and not everything is COSE. In fact, the reason we need to have those internal fields in the receipt is because there are non-COSE parts that are specific to CCF. The whole point of the profile is to explain that we can carefully surface the COSE part so that we can comply with the SLID architecture and the COSE receipt. RFC without changing the rest of the CCF implementation.
Yeah, and this is basically illustrating the actual value add of SCID and the COSE receipt verified data structure registry we have here. You do not have to change your running system. Whatever you have in place can be augmented with SCID, or you can start anew from scratch via the reference API, for example, and the SCID core specification. Whatever where you start, this can be in the end then interoperable. And that was the whole point of the exercise, so to speak. Yeah, and that was me. There, nobody else in the queue.
Okay, thank you.
Sure.
Thank you.
Okay, and with that, we are out of agenda items. Is there any other business that you would like to discuss now? Well, hearing none, thank you so much for your participation, and see you in our next meeting. Bye.
Thank you all. Okay, let's request publication on the two drafts. Why don't you do it and I'll pull up our instructions. These two. Multiple treat, right?
I think it's fine. Normally we'll need to click a button and they will go for the yeah.
I was about to message you that, and then nobody needs to know about any of this stuff, not because it's secret, but because they don't give a fuck.